Now, in case you do have some programming abilities, let's talk about malware reverse engineering. So what does it mean to reverse engineer anything? Reverse engineering means you take something, in this case software, and you try to take it apart to understand how it was built in the first place. It's kind of tricky with software because software always starts with just text, code, and it's compiled unless it's a script. But if it's an executable, it's compiled into what we call a binary that becomes really hard to turn back into code. It's challenging. But here are some approaches. So you could use a hex dumper to look for bit patterns. You could use a disassembler, and these are tools that programmers use, to read executable instructions in text format. You could just simply examine how the thing exploits. I mean, how does the malware actually do its thing? You could do that in a controlled environment. If the malware hides itself, if it scrambles itself, if it obfuscates itself, you could focus on reverse engineering only the new parts. You could look for mistakes in ransomware encryption implementation. Maybe you could crack the encryption. You could look for command and control activity where it's going out and getting marching orders from something else out there. You could do categorization and clustering. In other words, we'll take a bunch of samples that we think belong to the same category, and rather than do a deep dive into one single sample, we'll try to do some broad analysis on all of them. So techniques would include static analysis. I'm just going to look at the binary without running it. I'm looking at metadata in the file. I'm trying to disassemble or decompile it. Or dynamic analysis. Let the thing run in a sandbox, see what it does. Or automated analysis. We could use automated tools to help, but they don't catch everything, so it should just be part of an overall strategy here. And sometimes the malware might contain anti-debugging routines or anti-analysis capabilities, so you might do other kinds of analysis that are not typical. For malware analysis, there are a bunch of tools. In the first case, you need to have an understanding of assembly language. Now, assembly language is the lowest level language that is still something that is readable by humans. It's highly detailed in terms of opening up registers and opening up memory addresses and that kind of thing. Below that is machine code, which is what the CPU runs. So you need to have a good understanding of assembly language, really, if you're going to do this. The other programming languages are piled on top of that. There are tools. IDA Pro is a very common, venerable old disassembler. Debuggers like OllyDebug and WinDebug, these debuggers actually let you step through an application step at a time of what it does. There are process monitors and process explorers to watch the system. There are network monitors to watch network traffic. There are package identifiers and unpacking tools. There are tools to do binary and code analysis. Bunch of tools here that can be used for malware analysis. Here's just a screenshot of IDA Pro. This is something that lots of folks use. And so you can see here we've got different functions. We're actually looking at the code underneath, and we're looking at what's actually going on underneath here. So if you want to get involved in decompiling, deconstructing, reverse engineering, analyzing malware at that level, this is the information that can get you started.